Hello. Thank you for participating in today's webinar session. HVAC SAVE program, participating contractors. The purpose of today's session is to provide an abbreviated, highly abbreviated refresher on cool mode testing. Clearly in our area of the country, there is a smaller window by which to assess and verify cool mode performance. Certain outdoor conditions, certain ambient conditions need to be present in order for the air conditioning process to function and therefore be assessed and verified. So hopefully that this refresher will serve as a reminder of those key points as you proceed through this spring, summer, and fall. Okay, so beginning now with performance, cool mode performance, HVAC equipment. It's a matter of capacity and efficiency performance, okay? That's what you're selling. That's what you're delivering. Feels like you're selling and delivering a box, but really your sales process, your load calculations, your interviews, so on and so forth, have determined that what that customer needs is a certain level of capacity and efficiency. That's what we refer to as performance. Underperformance, which is realistic. Underperformance may or will adversely impact comfort, utility expense, and equipment reliability. Okay? So if that installed air conditioner or heat pump operating in cool mode, if it's under-delivering on its capacity and efficiency performance, then that will impact comfort. That will mean that the equipment needs to run more often to satisfy the load and therefore consume more electricity. And it also may affect the reliability of the equipment, particularly the blower in the outdoor unit. Okay, the underlying performance drivers, which you probably know now, are two things. The airflow, which is the medium by which the comfort is delivered to the living space, and then the air temperature, or in this case, the dehumidification of the air. That is the comfort itself, okay? So people want to be cool in the summertime, and they want to be cool everywhere throughout their living space. Performance faults. These are the most frequent reasons or causes for capacity and efficiency to be under-delivering, underperforming. 1, insufficient airflow due to high pressure conditions. Okay, so static pressure is just like blood pressure. There's resistance there. Resistance means that the comfort, the air temperature is not getting sufficiently to all the different places it needs to go. Or perhaps it's getting there, but not at the volume that it needs to be. Okay? So insufficient airflow. Too much airflow is also a fault. A frequent fault, okay? Nowadays, these blowers oftentimes ship out as a default on high speed. High speed may not be appropriate, and in fact probably is not appropriate for the needs of that outdoor unit. The overcharge and undercharge faults, okay? So again, the factories ship out a default amount of refrigerant. That's based upon an assumed line set, which rarely is the case in the field, okay? So it's possible that you've got an overcharge or an undercharge. And then duct losses, duct airflow losses, duct temperature losses, particularly in the supply run. Okay, let's talk a little bit more about airflow, all right? Here's sort of the most common configuration in our area of the country: entering air, leaving air. Airflow is the most important and the least understood performance driver. System efficiency cannot be attained if airflow is outside factory specified parameters. Capacity will also be affected. Sensible to total ratio will be incorrect, and the total capacity may also be incorrect. Adjust airflow first. Okay, this is what we refer to as the proper sequence. Dealing with airflow first. With a new installation, always set the airflow so that it's undeniable before taking temperatures and evaluating enthalpy performance and refrigerant charge. Always first. For an existing installation, always evaluate airflow first before evaluating enthalpy performance and refrigerant charge. Again, airflow always first. Let's touch on the airflow requirements for cool mode. These are set by the OEM based upon the size of the outdoor unit that you sold and are installing or maintaining. The SAVE program sets 400 CFM per ton as the nominal and has an acceptable range of 350 to 450. Pretty common in the industry. Now we do hear some OEMs dropping below 400. I think I was told one time that ASHRAE was steering the industry towards 350. Nonetheless, this is the acceptable range for the program. In the event that this does not comply or is in contrast to your OEM parameter, you simply need to tell us, send us that documentation, submit it along with the job, and that's how we'll verify it. Okay, acceptable methods of setting airflow. For a new blower, use total external measured static pressure, I should say total measured external static pressure, and the OEM blower charts. Okay, this is a fresh blower. The OEM gives us the data. It's typically in the install manuals. It's right there. Let's use it, okay? Now we are seeing more and more of these fully communicating systems in which our understanding is that in most cases the field professional does not set the airflow, rather the system sets the airflow. If that is the case, you need to identify that in the fan speed setting and you need to submit that paperwork or that logic, that language, the utility that explains just that the system and not the professional sets the airflow. Perfectly acceptable. Utility just needs to verify. Now, for an existing blower, you can use either total external static pressure, the measured total external static pressure, or you actually can measure CFM, the airflow itself, through a duct traverse or a flow grid. These latter two are more accurate, they're more convenient, they're certainly recommended, but you need to make sure you have that tool in your truck at that time. Thus, if you don't, you can still refer back to the blower charts. Okay, let's touch on the second driver, performance driver, refrigerant charge. Refrigerant charge is dependent on airflow, and incorrect airflow will result in suspect measurements and conclusion on refrigerant charge, okay? In other words, there's a dependency here, and that dependency is highly relevant, highly impactful. Refrigerant should not be adjusted until airflow has been confirmed and cannot be correctly set without correct indoor airflow. Again, reinforcing proper sequence, airflow first. Please don't mess around with your charge until you are totally confident in airflow, and also that airflow is correct to those OEM parameters. Okay, now charging refrigerant. Please do not assume the factory set charge is correct. That's based upon a certain line set, which is rarely the case, or oftentimes not the case, okay? You're a professional, you're a technician, your job is to make adjustments in the field, and you'll have a line set out there and you'll need to adjust the refrigerant charge based upon that line set. Now, SAVE does not require you to enter or provide us your refrigerant readings, superheat, subcool, or alternative. But we still expect that you will follow the OEM guidelines. Rather, SAVE evaluates refrigerant charge performance, again, capacity, efficiency, lower performance, all together taken as one, based upon the delta H or the enthalpy difference. Again, assuming that airflow is set and correct. I'll touch on delta H again a little bit later on. Okay, there are testing faults. In addition to installation faults, there are testing faults. One that we find more often than not, fairly frequent with cool mode testing is not getting accurate temperature readings. So let me share some stuff with you here, reinforce some elements from the original training that you enrolled in. Please use the same calibrated instrument for both dry bulb and relative humidity readings. Please wait long enough for those readings to settle in, and also take the entering temps and the leaving temps, the equipment temps if you will, at the same time. Okay? We've heard, I've not personally experienced, but we've heard that at times getting relative humidity to settle in takes a little bit longer than dry bulb. So if you're gathering the dry bulb reading first and you change the mode on your gauge over to relative humidity, pause and make sure that relative humidity settled in. Probably the best thing to do is take relative humidity first, and that way you know the dry bulb settled in. Be sure you are taking the leaving temperatures, the supply temperatures, approximately 12 inches down the supply plenum, not above the coil, 12 inches down, or in the plenum as far away from the coil as possible. And you may need to get averages. So let's elaborate on this here. You're in the temperature world now, so you've already set your airflow and it's undeniable. When you did that, you took static pressure readings. 4 spots, here, 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 and here. Okay? Now you're taking temperatures. You can use the same spot that you took your equipment entering static pressure in. May need to be a bigger hole for that probe, but that location is correct. However, your supply temperatures, your leaving temperatures are new testing ports, new holes, farther down away from the coil. We also recommend averages. In other words, if you get here, take one on the front, take one on the back, and take an average. And if you've got a T here, a trunk, take them over here as well and get an average. Okay, more on temperature and relative humidity readings. Depending upon the conditions, the ambient conditions and also the installation conditions, the anticipated or expected temperature drop may be between 18 to 22 degrees, give or take. This does not necessarily come from us. This comes from your OEM, so be sure to refer back to them, okay? But that's a rule of thumb that we hear. This is a fault that we experience. Relative humidity reading in the supply. Okay? I should not say a fault, I should say a testing error. Okay? Relative humidity is an indicator of moisture in the air, and relative humidity will be highest right after the coil when the air is most dry. Okay? Here's where the air is most dry. Here is where the particles per square area of that air are the most dense, and therefore where the relative humidity is highest. As the air moves through the supply and into the rooms, moisture is added to the air, air expands, relative humidity comes down. The comfort zone in the rooms, we hear 40-50%. Bottom line is that your supply reading is going to be higher than the comfort zone. Depends on the time of year, again, installation and ambient conditions, but it's going to be highest here. I think this is a bit against human nature. I think technicians feel uncomfortable with that. They pull their probe out too quick. They don't wait long enough. They may make that number up, so on and so forth. But just remember, it's highest here. Okay, now you're all done. You've entered it into the program software. You're taking a look at your reports and you're evaluating performance. Please be sure that when you do this, that you have used the OEM's expanded capacity table for the current cooling capacity. Please do not use the AHRI rating. Please do not use the standard specifications. Please use the OEM rating. The OEM will tell you, based upon outdoor temperature, based upon entering wet bulb, possibly airflow, what that total expected capacity is, and also what that sensible to total ratio is, okay? At this point, it's not the AHRI lab. And the OEM does not know what time of year that equipment is getting installed, or whether it's Des Moines or the Quad Cities or Honolulu or Miami or Austin. That is the purpose of them providing you those performance tables, those expanded capacity tables, all right? They're also used for design considerations. Most importantly, if you need to troubleshoot, you don't need to talk to the program. You don't need to call the program and say, hey, I don't trust your formulas. I don't trust your software. It's a non-issue because you basically are using the OEM data. You can call the OEM and say, hey, I don't trust your data, or why am I getting something so different, okay? That puts you, the contractor, and us, the utility, on the same page. Very important from a trustworthiness standpoint and from a verification standpoint. Okay, a qualifying score for an air conditioner or heat pump in cool mode is 85 to 120, with 100 being the OEM current cooling capacity. So what the OEM said to expect, current cooling capacity, is reflected here. That's 100. This is what you're measuring. This is the amount of cooling that the equipment is creating, and then this is the score. Okay, so this divided by this is your score. All right. Why can we go up to 120? Well, one, the OEM data is not infinite. They provide it in 10-degree increments. And two, there are a couple manufacturers that don't provide data down below 85 degrees, and we're in a cold weather market, so we're doing a lot of work below 85 degrees. Okay, verifying this before you send it in. We always recommend the field professional approves his or her own work remotely first. Field professionals never had visibility as to how things are happening until now. That's a benefit to this program. Take advantage of it. Look at the information. Look at the BTU relationships. Look at the quick review. Approve the work yourself. That's going to go a long way to a smooth file. 2, we always recommend the supervisor puts a second look and approves. Okay? Supervisors never had visibility on that field professional's work. Now that supervisor has that visibility. If these two things are done before it gets to the utility, the likelihood of a quick, convenient, and uninterrupted claim goes way up. Remember, the verification experience here is very much like paying taxes. You complete the forms yourself, you attest to its truthfulness and its accuracy, you submit and you accept an audit, and sometime after that submission you will hear and say, hey, we accept it or we don't accept it, okay? If you get through A and B before you send it to the utility, the likelihood of C happening really quickly and conveniently goes way up. Now, when they receive it, here's what they're going to do. They're going to look at the score, and they're going to make sure that it has a passing score, and then they're also going to verify the underlying performance drivers. So one they're going to look at is going to be the OEM current cooling capacity. Okay? Is it correct? This is the mark. This is what the OEM says. This is how we need to compare performance. Are you using it? Sometimes contractors don't use it. That's an indication to the utility as to whether or not you're using the OEM data. Attention to detail, thoroughness. They'll verify that number. They will always verify airflow, CFM, static pressure, blower setting. Again, that's the proper sequence. They're following the same proper sequence that you are. Airflow can be verified remotely fairly conveniently. Okay? They don't necessarily need to, but they may look at delta H. Okay? Keep in mind that if it's got a passing score, and if they can verify your current cooling capacity and they can verify your airflow, then refrigerant charge must be sufficiently calibrated. Okay? So they really don't have to look at this unless they just cannot reconcile some of these other numbers, which obviously can happen if it's a communicating stat and that technician is not submitting CFM based upon what's on the OEM blower charts. It may be that the verifier just wants to give you an idea. Hey, are you sure? You know, that doesn't look right. Troubleshooting. What if I cannot get a passing score? What do I do? Number one, please check to make sure it's not a data entry error. Happens more often than you might believe. Number two, did you get accurate temperature readings? Happens more often than you might believe. Took them in the wrong location. Didn't wait long enough. Didn't understand the relative humidity concept of it being higher and highest in the supply. Okay? Or you made them up. In cool mode, you have a more complicated conversion. You have the psychometric chart with the enthalpy conversion. It is more obvious when you're making temperatures up. Okay? Number three. All right, let's say I know I didn't have a data entry error. I got really good temperature readings. Now I better follow the proper sequence and look at my airflow. Is it set and is it correct? Okay? Improper airflow will flow all the way through to the final score, and you just cannot see it easily. So you have to get in. You have to feel very comfortable that that's an undeniable number and it's correct. Is it within the range? How is it reflected in the blower chart based upon statics and setting? Okay. Did you even set airflow for cool mode? That's a traditional behavior, particularly for AC changeouts only. Okay. Got to do it. The OEM says you got to do it. The outdoor unit's looking for a certain amount of airflow. The utility program is just simply looking to verify that you did it. Did you make airflow up? All right, so I know I don't have a data entry error. I know I got accurate temperature readings. I have undeniable airflow. Well, the only thing left is refrigerant charge. Okay, that's another benefit of following the proper sequence. So at that point, you'd move into your OEM approved refrigerant charge, calibration, and verification methods, superheat, subcool, weighted method, whatever. Once that's done, then you'll have to rerun through the performance verification process. Now it's possible you could find an OEM fault or OEM data, bad TXV valve, maybe the blower chart's wrong. All those things will also be uncovered. Okay, doesn't mean that it'll pass the utility program, but you certainly can isolate it down to an OEM fault as opposed to a contractor process fault. Okay, last thing on delta H again, you don't necessarily have to look at delta H, but it may be helpful to you, particularly if you need to troubleshoot. This is only a rule of thumb, but it might be a good rule of thumb for you. If you have a delta H above 7.6, or below 5.9, give or take, that probably means that airflow is off, refrigerant charge is off, or both are off. Point being here, if you kind of set a range here and used it as a secondary source of information, hey, I'm real close to the bottom or top of that range, or I'm outside that range, I better take a second look at everything. That is what we would recommend. Okay? It's not too dissimilar from temporize, except that it's not a manufacturer spec like temporize is, but it is an acceptable range. It is a secondary look as to whether or not you might have a fault with airflow charge, or possibly a testing fault. Okay, last slide. I just want to touch on AC swap outs only. This is a very difficult, or can be a very difficult situation for a field professional, but it's not terribly uncommon. Remember that the blower is still in the furnace most often, but it's certainly not in, you might have a blower coil, but that's pretty rare. But the blower is typically in the furnace. And the cool mode performance, the outdoor unit of what you're selling, is dependent on the blower and the dehumidification processes. Okay? You simply cannot ignore airflow in cool mode just because the blower is in the heating equipment. Common behavior, common fault. Okay? To the customer, you should educate your customer. You should explain to them that the blower is important, that it's the medium by which your coolness will get to where you live, sleep, and work, that blower is actually in the furnace, that the HVAC industry has a matching process where you match blowers, furnaces, and air conditioners together. Recommend that the very best solution for their comfort, efficiency, and reliability is to purchase a matched system. Okay? The field professional will still need to set airflow. No matter what, they're going to need to set airflow for cool mode based upon the needs of the outdoor unit that you sell, regardless of whether the customer purchases a new air handling unit or not. So if you can't persuade the customer to buy a full system, matched system, only an air conditioner, and they still want a rebate, okay, you can still make that efficient, but you have to get in and work on the furnace, on the blower part of the furnace, as it relates to the OEM requirements for the outdoor unit, okay? That assumes that it can happen. We run into situations where it's an AC swap out only, and there's just no way that that existing furnace can give the outdoor unit the airflow that it needs. Recommend on a pre-sale basis that you take a picture of all nameplate data on everything, indoor unit, outdoor unit, furnace, so that if in the event you cannot persuade the customer to buy a new matched blower to go with that air conditioner, you can at least provide the field professional a manufacturer name and model number for that furnace so they can go source those blower charts before they dispatch. All right, that's everything. Wanted to thank you so much, and have a great spring, summer, and fall. Look forward to working with you.